All right, so today we're diving into this absolutely fascinating world of tech that lets us, well, see the unseen. We're talking about everything from tiny pollutants to the very first signs of a disease, things that are completely invisible. So, how exactly are scientists making the invisible visible? Let's get into it. And really, that's the big question, isn't it? I mean, think about it. How do you possibly detect something you can't see or smell or touch? We're talking about things on a molecular level, tiny particles that can be a massive threat to our health, to the environment. And that, right there, is the huge puzzle that scientists are trying to crack. Yeah, and this isn't just some cool science experiment, you know? This is a critical, real-world need. We're talking about finding better ways to spot diseases way earlier, keeping an eye on dangerous gases, and just making our industries safer for everyone. The stakes here are, well, they're incredibly high. So to meet this massive challenge, scientists are turning to two pretty revolutionary materials. You could almost call them the microscopic heroes of our story today. Get ready to meet graphene and a class of materials called metal organic frameworks, or as we'll call them, MOFs for short. Okay, first up, graphene. Now, I want you to picture a sheet of chicken wire, but it's so unbelievably thin, it's only one single atom thick. That's literally graphene. It's just one layer of carbon atoms. And the magic part, the reason it's so good for sensing, is how electricity flows through it. Electrons just zoom across its surface with almost zero resistance. What that means is it can pick up on the tiniest, most subtle electrical change. That makes it a perfect, super-sensitive foundation for a sensor. All right, so our second hero is the metal organic framework, the MOF. And if graphene is our atomic chicken wire, then you can think of a MOF as a kind of molecular sponge. It's this really cool crystalline structure built with metal atoms connected by organic molecules. And all together they create this framework that is just riddled with tiny empty spaces. It's incredibly porous. And when I say porous, I mean it's just staggering. Get this, up to 90% of a MOF's total volume can be just empty space, pure void. That means it has this gigantic internal surface area, which makes these little sponges absolutely perfect for trapping and then detecting any specific molecules that happen to wander inside. So, okay, we've got these two amazing materials, right? Graphene and MOFs. But, and there's always a but, here's the catch. Just having this raw potential, it's not quite enough. The real mountain to climb is making them sensitive enough to detect just the tiniest trace amounts of something. We're talking about spotting just a few molecules in a sea of billions. And that, right there, really gets to the heart of it. The cutting edge of this research, the #1 goal for scientists in this field, is all about boosting the power, boosting the sensitivity of these materials. So the big question is, how in the world do they do that? Well, it turns out they've got a whole toolkit of different strategies, all designed to enhance or, power up these materials. See, scientists don't just grab graphene or a MOF off the shelf and call it a day. Nope, they customize them, they upgrade them for very, very specific jobs. And the process itself is actually pretty logical. You can think of it in a few steps. First, they start with their base material, that graphene sheet or the MOF sponge. Then they apply one of their special enhancement strategies, which we're going to look at in just a second. And voila, the result is a specialized sensor perfectly fine-tuned to be hypersensitive to one specific thing. So what's actually in this enhancement toolkit? Well, they've got all sorts of cool tricks. For instance, they might add conductive polymers. Think of it like paving a superhighway for electrons to move electrical signals even faster. Or they can make a material luminescent, which is awesome, because it means it literally glows when it finds what it's looking for. Other strategies? They might decorate the surface with these tiny metal nanoparticles to really amplify the signal, or use electrochemical techniques that measure chemical reactions. Each one is a different way to seriously power up that sensor's sensitivity. Okay, so let's circle all the way back to the beginning. We've got these super-powered materials, so what can we actually do with them? This is the part where stuff that sounds like science fiction starts to become science fact. We're talking about solving real-world problems that affect every single one of us. And the applications are, well, they're genuinely life-changing. We're talking about sensors that can detect dangerous heavy metal ions, think mercury, in our drinking water. We're talking about devices that can precisely monitor CO2 levels to help us track climate change. In the medical world, they can spot cancer biomarkers from a single drop of blood. And for security, they can pick up on the absolute faintest trace of explosives. Just amazing. And this is really where you can see it all click into place. It shows you exactly how scientists are matching the right material and the right enhancement strategy to a specific task. So, for example, if you want to detect CO2, you might use a metal-organic framework with an electrochemical sensor. Need to find heavy metals in water? Graphene oxide boosted with a conductive polymer is your go-to. And for finding a cancer biomarker, you'd use a special kind of MOF that's designed to fluoresce, to light up when it finds its target. It's all about picking the perfect tool for the job. So all of this brings us to a final, pretty powerful thought. We are right on the edge of an era where we can basically create a sensor for almost anything. And that leaves us with a huge question. It's not just what we can detect anymore. The real question is, what are we going to discover about our world, about our own bodies, and about the universe itself when we finally have the ability to sense everything?